Hello, Olathe West Owls. Welcome to another day of ACT Math Prep. We're going to be doing probability part 2 today. Now, if you have not done the probability video from last time, stop this video right now and go to it, okay? It would have been the ACT Math video number 2. Again, if you have not done the first probability video, please stop this video now and move on to ACT Math video number 2. That's our first probability. Now, what do you need for today? Well, first of all, you're going to need to have some materials. You need to have your graphing calculator. You will also need to have paper and pencil/pen to write with. There are some of you are using dry erase boards, which is great. In that case, get a marker and something to clean off the board with. I'll give you a second to get those materials together. While you're doing that, again, graphing calculator is important to use. I know many of you have cell phones and you're using those calculators. That's great, but you will not be allowed to use those on the ACT. So all of our preparation work, we should be using the actual materials you would use on the ACT. Like we're using actual questions, you should be using the actual calculator you are allowed to use on the ACT. Okay. Now you can download the materials that we're using today. You don't need to, but let's say you want to have some practice questions that you want to use when you go home. Go to our page, our YouTube channel, and we have a link right there that'll take you to a Google Drive with all the materials that we have. All right, so without further ado, let's go ahead and get started on these questions. Now, probability, we're going to deal with compound probabilities here. And the formula is, you got to remember, like in math class, when we say the word and always means to multiply. So, well, this is great with the focus here, huh? See if we can get this to go better. Oops. That's fun. One more. All right, we'll see how this goes. This is question number 47 from the ACT, and it's really not that bad. It says you've got 30 solid colored marbles and the player is randomly drawing marbles from the bag. Here's how many marbles are of each color. You're going to be picking 2 marbles from the bag, one after the other. And the key is without replacing the first marble. So when I pull a marble out, there'll only be 29 marbles to pick them from. What's the probability that this person will draw a black marble followed by a green marble? So the probability of black times probability of green, because that's what our formula for probability says. Probability of 2 things happening is the product of each of those probabilities. Now, the probability of drawing a black marble, we can look, is 6 out of 30. And the probability of drawing a green marble, well, there's 2 green marbles, right? But there's no longer 30, right? There's going to be 29 of them because, again, it says without replacing the first marble. Now, don't do this by hand. Use your calculator, right? Multiply them out. This turns out to equal 2 out of 145, and that is our answer. And again, this is number 47. It's not really that bad. Okay, I would like you all to try this question. It's number 48. I think you can do it. I'm going to give you 20 seconds. Okay, 5 seconds left here. Okay, now they're telling us something here. It's 2 independent events. That means one doesn't affect the other. And they want to know what's the probability of A and B happening. Well, that would be the probability of A times the probability of B. So 0.2 times 0.4, and that results in 0.08, letter F. Again, that's number 48. That's that high ticket kind of questions. There's some nice ones at the end of the test there. Definitely take advantage of those. Okay, here's another one. It's just like these, right? But it's a little bit different. And I think it was helpful on this, like this one, I think is a true number 49. I think those previous ones, they could have been in the first 10 questions. We should write down the information as we see it. Like we can see here, they estimate the team has a 60% chance of winning on Saturday. So I should say probability of winning on a Saturday is 60%. And it says only a 35% chance of winning on Sunday. Okay. Now, using these estimates, what's the probability that the teams will, now look closely, lose both games? So, you know, as ACT is not really cruel, they don't have the answer of when you multiply these two things out. They're not appearing there. But I think you would agree that if the probability of winning on Saturday is 60%, then the probability of losing would be 40%, right? We'd write that out as a decimal. And the probability of winning on Sunday is 35%. That would mean losing is 0.65, right? Or 65%. If we multiply those, right, because we're going to multiply these out, it's the probability of this and this, right? Two things happening. We're going to end up with 0.26, which is 26%. Not too bad. Okay, let's look at ones that are a slightly a variation of this. And as I've said before, the more math questions you can practice, the similar questions you start to see. Like these two questions are from different ACT exams, but you notice they look pretty similar. We're going to do the one on the left together, and then you're going to do the one on the right. The one on the left says we've got some different sets, A, B, and C. They want to know what is the probability that a selected number will be an element of C and B. Now we're selecting them from A. So if I'm going to pick a number from A. Now, if I think about possibilities, there are, you know, there's 9 different possibilities here for A, right? So the total possibilities are 9. But how many of the numbers could we pick would also be in C and B? Well, if I look here, I notice the number 4 is in both C and B. I also notice the number 8 is in both C and B. So 2 9s, right? There's 2 possibilities that are in both. So letter G. Okay, your turn. You're going to do this one, and I'm going to give you, oh, I think 30 seconds would be fair. Okay, 10 seconds left. All right. So we're randomly selecting something from A. And what's a probability it will be in B and C? Well, there are 1, 2, 3, 4, 5, 6 things in A. So the total 6 of them, right? And which one of those are in B and C? Well, I notice the number 2 is in both of those. That's really it. So 1 out of 6. Hopefully that's what you had selected. Okay, now there's another type of probability. It's called conditional probability. Well, I'm sorry, not conditional probability, but we're doing an or now. This or that. And with ors in math class, we know that we usually always add them up. Now, the thing is, with these ors, you've got to be careful. And these ones usually, if you want the numbers, 40, 56, they're definitely tougher questions because people always forget to subtract the overlap here. Because what happens is you're going to add up the probability of A plus probability of B, chances are there's gonna be something that's an A and B. We're gonna end up counting it twice. And so we've got to subtract it to make sure we're not counting it twice. Okay, well, let's look here at number 40. Box contains 6 objects. There's a total of 6 things in there. Now it says 3 are discs. So I'm gonna put down there are 3 discs. And of those discs, there are 2 blue and 1 red. So 2 blue, 1 red. Just trying to organize my thinking a little bit. And then he says there's also 3 triangles. There's 3 triangles. 1 blue, 1 red, and 1 yellow. So 1 blue, 1 red, 1 yellow. It says it's a probability of drawing each object is the same. What is the probability that an object drawn from the box is blue or a triangle? So the probability you are blue or a triangle. Well, we know, according to our formula, the probability of A plus B. So the probability of picking out a blue. Well, there are 2 blues here and 1 blue here. So there's a total of 3 blues out of 6. Now, a triangle. Well, we're told there are 3 triangles. So 3 out of 6. Now, if we were to add those up, we would get the number 6 over 6, which is 1, which is not a choice. So ACT was at least a little nice with that. We've got to subtract the overlap. I think we counted something twice. I think we counted this blue triangle twice. This blue triangle got counted in with the triangles, also with the blues. So we have to subtract out that blue triangle. And that will give us an answer of 5/6. All right. I want to give you a chance to do this same idea. They're doing it with cards instead. It's kind of like an Uno deck here. Now it's number 56, and I'll read it with you and then give you time to work it. It says there's 100 cards, right? There's 5 different colors, and the cards are numbered. There are 20 of each color. Okay, so there's 20 of each color, and the cards are numbered 1 to 20. They're going to pick one random card. What's the probability? So probability that the selected card will be blue or 17. So probability you'll be blue or 17. Okay, I'm going to give you again 30 seconds to kind of think this one through. Okay, now there's lots of mistakes people could make, but we got to remember there's 100 cards out there, right? So the denominators for all of these will be out of 100. I think that kind of helps us not make some mistakes, because I could see people doing some different things here. Probability of picking a blue card. Well, we're told there are 20 each of the colors, right? So there would be 20 blue cards. Now, how many 17s are there? Well, we're told that each card is numbered from 1 to 20. So it makes sense that there will be a 17 in the blue, the red, the yellow, the green, the orange, and so on. There's 5 of those. Now notice that answer is here at letter K. That is not correct, because we got to subtract something. We actually counted the blue 17 twice. The blue got counted in with the blues, and the blue got counted with the blues, and the 17 got counted over here. This blue 17 is in both pieces. We can only count it once. So let's subtract it from there. And now we'll be left with letter J. Okay, again, these probability, I want to make sure we do these first, because generally these are things that you really haven't seen before. And there's a good chance you'll have between 6 and 7 questions dealing with probability. Okay, here's another one. And this is like number 52, right? A lot of reading here. Read, 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 read. They want to know what is the probability that the ball that is drawn will be red or have a 3 printed on it. Okay, well, let's think about it. Probability, you're going to be drawing red or the 3. Well, that will equal the probability of red plus the probability of getting a 3 minus the probability of a red and 3. Well, how many reds are there? Well, we're told there's 10 balls, right? There's 3 red. So 3 out of 10. Now, let's see how many 3s there are. See, the blues are numbered 1 and 2. The reds are numbered 1, 2, and 3. So there's 1, 3. And then the green are numbered 1 to 5. So there's another one for that. So there are 2 out of 10, right, of 3s. But we better subtract out. There's a red number 3, right? This red ball that is number 3 got counted twice. This red 3 got counted once here and once here. So let's subtract that overlap and we'll wind up with 4/10. Letter J. Okay. So let's go back to some beginning probabilities. I want to give you, let's try to do these quickly. Now, make sure you have your calculator ready. And I want to give you 15 seconds per question. Okay, so here's the first one. And by the way, this was question number 1 on an ACT question. Go. Okay, 10 seconds. Okay, now, some of you probably saw, wait, there's an or there, Mr. Flynn. We should be subtracting the overlap. Well, let's pretend we are going to do the overlap. It'd be probability of red. Now, when you're doing the ACT, hopefully you are not writing out all this stuff that I'm writing. Hopefully you're just putting numbers down and working it through when you take the actual test, right? This is practice. You want to be able to look back and see what you did. Probability of red and blue. Okay, probability of red is 5/19. Probability of selecting a blue is 4/19. Is there an overlap? I think there's no marbles here that are both red and blue, so we'd be subtracting 0. Well, when we add these things up on our calculator, we get letter B. And again, I think we could have added this in our heads too, right? 5 plus 4 is 9. 9/19. Might be quicker that way. All right. Here's number 24. Very similar question. This one, I'm only giving you 10 seconds. Go. Five seconds left. Okay. Now, there's a couple things here. There's a vocab word here called mutually exclusive. That's what happened over here. There's no overlap. There's nothing going on here. Even if you did not know what mutually exclusive meant, we just look here, event A or event B. So the probability of A, which we're told is 0.2, or means plus, event B is 0.6, letter K, 0.8. Even if we didn't know what mutually exclusive meant, we've got it. Do you notice there's a 0.12 there? Thinking someone might try multiplying these. So you got to remember, when you see an or means adding, when you see the word and, it means to multiply. Okay. So fantasy football, just in time, right? Football season started this week. I'm going to give you, and the key is here, whenever you see a table, go right to the question mark and see if that is all you need to read, okay? I'm going to give you, 15 seconds on this one. Go. Okay, it's time. So the probability they will be a kicker or a receiver. Well, kicker, there's 4 out of 20 of them, right? And then a receiver, there's 8 of those, so plus 8 over 20. Now that adds up to be 12 out of 20, which we don't see as a choice. But if we reduce that fraction, we will wind up with 3/5, which is letter K. Cool. All right. Do number 18. It's just like it's on a different ACT test, but again, similar questions. 10 seconds. Go. Okay, now I'm betting if a lot of people are reading on the top here, you wouldn't have gotten it done in 10 seconds. When you see a table, just go backwards to the question mark. What's probability that an outfielder or a pitcher? Now, outfielder is 7, right? 7 out of 25. A pitcher is 8, so 8 out of 25. We add those up and we get 15 out of 25. Now we do notice something kind of interesting here. When I glance at the answers, they're all percentages, which means I've got to divide this, right? 15 divided by 25. Use the calculator. Don't do it by hand. You can punch it in faster. This is equal to 0.60, which is 60%. Okay, cool. Now, some of these probability questions, we have to write out something called a sample space, which means all the possibilities that could happen, right? It's a little quicker that way. Now, notice these 3 questions are like numbers 58, 58, 59. They're at the end of the test, right? They're here to be challenging, and these ones are, but if you write out the sample space, it's not too bad. Okay, 58 says you've got 4 golfers, and you're going to put them into 2 groups of 2. Now it says Jill and Ramona are among the 4. What's the probability they'll be paired together? I don't know. Let's make up all the choices. We could put Jill and Ramona in one group, and then I could put in person A and person B in the other group, right? This is one possible pairing we could have. Now what I could do, instead of pairing Jill with Ramona, I could pair Jill with person A. Well, that means Ramona's got to be with person B, right? So here's another possible grouping for the day. I could also pair Jill with person B. That means Ramona is going to be with person A. So Jill has been paired with every single person out there. And if I look at Ramona, Ramona's been paired with every single person also. Well, this is the only time that they are paired together, right? So that would be 1 out of 1, 2, 3, 1/3. A lot of people want to select 1/6, right? Because you're like, well, here's the grouping. No, when you pair these people up, they have to get paired up here too, right? So this is one possible choice. Jill and Ramona are together, and person A and B are together. All right. I'd like you to write up all this as a sample space. We've got 5 balls numbered 1 through 5, right? And you're going to pick 2 of them at random without replacing. Okay, so that means I couldn't pull out a 2 and then pull out another 2. What's the probability that the sum of the ball numbers on the balls drawn is 7? Wow. Well, let's write down all the possibilities. If I pick ball number 1, then I can pick ball number 2, right? Or I could pick ball 1 and ball 3, or ball 1 and ball 4, or ball 1 and ball 5. I think those are all the possibilities if we had selected ball 1, right? Now, what if we select ball 2? Well, we've already got 2 paired with 1. 2 can't be paired with 2, so it'd be paired with 3, and with 4, and with 5. Let's try ball 3. Ball 3 has already been paired with 1, been paired with 2, so it'd be paired with 4, and be paired with 5. Let's go up to ball number 4. 4 has been paired with 1, 2, 3. Let's pair it with ball number 5. There's a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 possibilities. Now, there are some probability formulas we could use to come up with that, but it's just as easy just to write it out here. It's not going to give us a massive amount of numbers to do. Now, which ones give us a sum of 7? Well, I do believe that 2 plus 5 is 7, and 3 plus 4 is 7. I think that's it. So 2/10. I don't see 2/10 in the answers, but this does reduce to be 1/5, and I do see 1/5 in the answers. Okay, that wasn't too bad. Now, a couple years later, ACT did a very similar question, but they put more numbers in there, right? Instead of just being a collection of 5 different balls, it's 2 different sets, A and B, and they want to know what's a probability that A times B is greater than 0. Now, we could do some other math stuff on here, but I think it'd be helpful again to write out all the possibilities. So like we could have number 3 picked first, and then it would be paired with number 2. I could pick number 3 and then be paired with -1. See what I'm doing? I'm just kind of pairing up the first number, -3 from that list, with everything in this list. And there they all are. Then I'll do the -2. And so I've got the 3 done. Now I'm doing the -2. And I know there's way quicker ways to do this, but there's -1 be paired with -2. Hopefully by the time we have this written out, you'll see why writing these out, I think, is the way to go. And then the last one, 1. Okay, those are all the possibilities. And if I count all those up, right, there's a total of 20 of them. Well, I know I can get rid of A. There's no way it's going to be out of 200. Now, they're telling us the probability that AB is greater than 0, so A times B. Well, that means a negative times a negative, right? Isn't a -3 times a -2? Isn't that going to be a positive number? See, I think we might have missed some of those. I think when someone's going quickly, they'll go through here and go, oh, A times B. I think they both have to be positives. No. They really both just have to be the same sign, either both negative or both positive. Okay. In fact, there's the only positive times a positive. If I add all those up, there's 7 of them. So 7 out of 20, letter D. And again, that was under a minute, that wasn't too bad. Okay. Your turn on this next one here. And I want to give you a full minute to do this one, okay? Go ahead and begin. I'm just going to start writing some things out while you're still working. Okay, so what I did was I wrote down all the multiples of 20 that are less than or equal to 300. The question says, what fraction of these integers are multiples of 15? First off, there are exactly 15 numbers here, right? Now, multiples of 15. So which numbers could 15 go into? Well, 15 can't go into 20, and it can't go into 40. 15 does go into 60. So the first thing I should do, since 15 goes into 60 4 times, right? So I should find all the multiples of 60, like 60, 120, 180, 240, all the numbers that 60 could go into. And you know what? That's everything that's a multiple of 15, because that was the lowest. This was the lowest value that 15 went into. Looks like there's 5 of them. 5 out of 15, which reduces to be 1/3, which is choice F. Okay, now I know we always want to keep these at 30 minutes here, but I do want to, there's some really fun ones I'd like for us to take a look at, because I want to show you just one. Okay, we'll do one more. This is going to be it. Now on the packet, right? We're going to do this one together. But if you download the probability materials, right, from our Google Drive, again, the link's on the banner for our YouTube channel, you should try to work out this other one here. This one's, it's a good test taking strategy. This one is. Now it tells us how many marbles we have, right, of all these different things. Here's the interesting thing. How many additional red marbles should be added to the 34? So the probability of picking a red marble is 3/5. Now, I'm not very good with fractions. I'm pretty good at decimals, though. And if I were to look at this one, the probability of drawing a red marble would be 0.6. If I were to do 3 divided by 5. So I want it to be 0.6. Let's see what it is right now. There's 12 of them. So the probability of drawing a red marble at this moment is 12 out of 34, right? 12 marbles out of a total of 34. Now, if I divide those out, I'm going to get about 0.35, nowhere near 0.6. So we're not going to do a lot of math on this to figure it out, or algebra. We're just going to plug in numbers and see. If you look, these are all the possibilities. Whenever you, now on ACT, it's a little pro tip here, the numbers are always in increasing order. Okay, they get larger, like if even fractions, right? 1/15. See, these fractions are getting larger as you go. Always true. So what we're going to use that to our advantage. We're going to do some guessing and checking here. This will focus. There we go. So I'm going to guess the middle number, 29. And here's why I'm going to do it. If 29 is too many marbles, well, then guess what? So are these. It gets it down to a 50-50. Let's say 29 was too much. I'm sorry, was too little. Well, then 16 and 21 are also too little. So I'm going to try 29. That would mean the probability of a red marble would be, right now it was 12 out of 34, right? That's what it is. Well, let's add 29 red marbles. And that also means that there's 29 additional marbles in there. Use my calculator to add these up, right, and divide. This comes out to be 0.65. And that's going to be too much. So 29, again, we're trying to get it down to a 0.6. Well, since that's too much, so are those. Well, look, now we're in a 50-50. And again, this didn't take maybe 30 seconds to do. Now 0.65, we're really close. I'll bet 21 is it, but I should just make sure, right? So let's try 21. I mean, the probability of red would be, well, again, originally it was 12 out of 34. Let's add just 21 red marbles. That means the total gets increased by 21. This is equal to 0.6. And that's exactly what we wanted. So the answer would be letter B. All right, hope you've enjoyed this. This is our last of the probability units. We're going to move on to some other topics, probably dealing with geometry next, because that's what generally a lot of students have trouble with. Thank you all very much. And again, don't be afraid to watch all the other ones too. They're pretty good. Take care. Bye-bye.